Perfect. Welcome, everybody. My name is Abelardo Pardo. I'm currently Dean of Programs responsible for Information Technology and Mathematics at the University of South Australia here in Adelaide. It is a pleasure to welcome you to another session of the 2022 edition of the Empowering Learners in AI conference. As you know, the event takes place over 3 days in multiple locations around the planet. Like I said, of Australia, where it is actually 6:34 in the morning on the Wednesday, December. And I have the pleasure today to introduce our next keynote speaker, Kumar Garg. Kumar is currently Vice President of Partnership at Schmidt Futures, a company connecting bright minds everywhere with opportunities to solve hardest problems. Kumar provided policy advice for the in the White House policy. He contributed to Kumar's STEM teaching to various initiatives in the K-12 space. Kumar is going to talk about the emergence of the field of learning engineering and its connection with the world of AI and how can it create powerful insight in the education space. He will also share with us some of the initiatives within Schmidt Futures in the area of learning engineering. Thank you for being with us here, and over to you, Kumar.
Amazing. Wonderful to be with everybody, and thanks for having me, and hello to everybody, no matter what time zone you're in. I'm based here in Washington, D.C., and so it's mid-afternoon here. So I'm going to do, I think we have about 55 minutes. I'm going to cover a little bit of our work on learning engineering and some of our motivating, both how I sort of got into the space, some of our current work. And we'll try to do that in about 30 minutes, a little bit less, and then we'll leave the rest for questions. So folks should feel free to introduce themselves in the chat. It's always great to hear who's here. And then if you have questions along the way, feel free to drop them and then we'll catch them on the back end. So I think the principal goal is I'm going to just give you a little bit of like my own personal story and how I got interested in education research and how we've been investing and working in this area. So first, let me just do a little bit of my background. So I'm an immigrant to the United States, came as, spent time in Britain, India, parts of Libya, and then came to the US, grew up and then learned political science and computer science in college, and then started working on the underfunding of the school system, first in Connecticut, and then got the opportunity to do a fellowship after graduate school into the White House in the Office of Science and Tech Policy. I had the opportunity while I was there to work a lot on education. President Obama was quite motivated on improving math and science education in the United States, and didn't actually have anybody in the science and tech office that had worked on education. So I ended up becoming the STEM lead for the president. This was one of those things where I'm a big believer in people serving in government. I did this on the right. This is me in my fellowship year, which is quite the honor, where I was invited to actually present to the president on what we were doing on math and science education. And then I stayed all 8 years. So the photo on the left is me 8 years later presenting to the president on what we were doing on computer science education. And you can see that I'm still my youthful self 8 years later, but the president has substantially aged as he takes on the hard parts of the job over those 8 years. But it was an incredible opportunity and pleasure. So I got to work on education throughout those years. It was about a third of my portfolio. And one of the things I got to work on was specifically education research, which was, as a science and tech office, we interacted a lot with the research enterprise overall, everything from biomedical funding to what we're doing in space, and also what are we doing in education research, which is predominantly done in the US through the National Science Foundation and through a part of Department of Education called the Institute for Education Sciences, as well as some of the other agencies like DARPA and others that dabble in this area. So I got quite interested in how do we invest in the future of learning science and what are the ways that the US government supports this, just like we support the other sciences. So let me go to the next slide. So part of what I did when I was in the White House was, I was interested in always setting compelling goals that align to the president's goal of improving education, as well as then thinking about what are all the different things people can do. So this was just many of the many things I got to work on, whether it was recruiting math and science teachers or building science fairs or building ways to get more kids connected to the internet. But in all of these, one of the things that always remarked to me was, there was a lot of energy and interest on improving math and science education from the delivery standpoint, but not nearly enough work that I was seeing on what I would call education R&D, which is putting education on the pedestal of thinking about how are we accelerating our insights for how people learn and deploying them, and putting that at the same plane of energy R&D or biomedical R&D. And so that was an area that I would continue to be interested. So then when I left the administration in 2017, in the beginning, as the new administration came in, one of the people I got a chance to start working with was Eric Schmidt, as he was finishing up his time at Google. That led to the creation of a new entity, Schmidt Futures, which works on the intersection of science and technology for the public good. And one of our missions, the organization is now 5 years old. It grew from an organization of 7 people to more than 150. And its real principal area is to really bet on early ideas and people. And so we're looking for exceptional people who are doing work. And we really break this up into 3 areas. So how are we finding amazing people at all different points of their career? How are we connecting them to really important problems, whether that's in astronomy and health and education? And then how are we creating platforms for them to scale, whether it's how to find co-funding, how to use policy, how to design market shaping instruments so that they can drive more impact at scale. And so I wanted to use the same formula when and start to think about what are ways that we can use this to accelerate work in education. So we started a program in 2019, about 2.5 years ago, on learning engineering. So this borrows heavily from work that's come out of Carnegie Mellon. Carnegie Mellon has been talking about learning engineering for close to 40 years. And the area that I was really interested in was what are the ways that we can accelerate the pace and relevance of education research, and what are ways that we can use new developments in how science is being done and think about the world of learning science. So let me just sort of articulate what I think is important and what the need for a learning engineering approach is. So there were 2 sort of things that I sort of, when I talk to PIs in this space and researchers, that come up all the time. So the thing that learning researchers will always point out is that fundamentally the design and workflow of learning science research has not fundamentally changed in quite some time. So most faculty members, even when they raise money or they get a grant from the NSF or anywhere else, are basically doing a full project from beginning to end. They're recruiting the students, they are designing the experiment, they're having what way they're going to run the experiment, they're collecting the data, and they're publishing the results. They're doing all of that within the context of a single grant. And there's very little shared infrastructure, which means most education research ends up being quite slow to put together. It can be years to collect the relevant data. It's quite small. So, a paper might study 30 students. And then, there's a huge sort of challenge in the field for how do you generalize these results and what do you do with them? At the same time, you have this huge world of ed tech and others that's grown up, and folks who are trying to do educational delivery. And their general view of education research is to say, like, oh, I need to do some research to show, quote unquote, my product works, but not how do we actually embed a research and experimentation engine into how my products improve. So neither the scientists are getting particularly well served in the current model, nor the engineers who might want to develop this. So the way we thought about this, when we go to the next slide, is what might be ways that we could actually make investments where ultimately our goal is to drive improvements in educational outcomes, but by leveraging what is actually accelerating the pace of science itself. And the thing that we focused in on was computer science, which is, it's the thing that is accelerating science the most. And so we asked the question, how can advances in computer science accelerate the pace, the relevance, and the use of learning science as a discipline? And so we thought about that in a few ways. So I'll sort of give you like a couple of examples of like why, this might be important. So one big area in education is, ultimately education in most instances is delivered from teachers to learners, some version of instructor and learner. But as most people know, in classrooms, there is one instructor, many learners. That's true in lots of contexts. And so one of the big challenges in education in general is how do you optimize that time? Teachers don't have enough time. Teachers will always talk about that. That's a big problem. But optimization is a really powerful computer science problem. And what are ways that we sort of increase optimization of that time? So that's one big category. Why don't we go to the next one? Second one is motivation. So we're coming out of this huge pandemic. And one of the big things that we find is that human to human interaction is motivating. Human to computer interaction can sometimes be motivating, often is not motivating. But like ultimately motivation is the real lifeblood of learning. Students who are in a high motivation loop can end up being in a huge ability to learn. They can, but we don't actually know what are the ways technology can actually supercharge motivation. How can it detect affectation? How do you put humans in it? How do you actually, come back to things you really learned? The second big category where technology might, or computer science be able to help, is supercharging motivation. And then the third one is, education is, predominantly experienced through words, right? Like you have writing, you have reading, you have math content, educational delivery happens verbally. There's just a lot of text. And one of the big questions is like, in a enterprise that is largely communicative and is done through words, what are ways that natural language processing and the rise of LLMs can actually create? So those were, I think, three as a sort of general ideas that we were interested in. And so then the big question we wanted to sort of focus on was, well, what are ways that advancements in computer science can actually accelerate, as we said, the work of learning science? And what are ways that you create intersections? So we thought about that in three ways. So one of the ways that we sort of thought about it was, and I'll go into each of them. So one of them is platform instrumentation, which is what is the way that rather than researchers having to do all of the work, recruit all the students, design the experiments, launch experiments, collect the data, what are ways that they can actually start to have platforms where they can run their research experiments? Now, this exists in other fields, right? So if you're an astronomer today, you're not building your telescope. You're actually working off really large instruments that are jointly funded by the field. That's true in physics. That's true in lots of biomedical innovation. So what are the platforms that would accelerate research? What is the way that we allow this computer science talent to enter this field? So we start to create more folks who are bilingual. And then what's the way that we actually have what's happening in the learning sciences actually affect the market? And what are ways that we can improve the loop between those? So let me go through those three. So first, on platform instrumentation, I think one of our hypotheses, and it's still playing out, is that the big thing that's changed over the past 10 years is that we actually have the rise of really large digital learning platforms. And by that, what I mean is, as more students are learning online, especially obviously the pandemic increases substantially, especially in the middle grades and older, you're just starting to have really large learner bases that are in one system. And one question we wanted to ask was, to what extent can those enterprises, those digital learning platforms, actually function as a research hub where researchers, rather than having to recruit students independently, can actually show up on a digital learning platform and in instances where it can actually improve learning outcomes, design and launch experiments to improve the learning outcomes of that platform, but also to actually advance the state of learning. So you start to have something that creates a performance loop that both improves that individual case, but actually advances the science of learning itself. So we went through a walk around and started to interview lots of large scale platforms and said, what would it take for you to actually start to build the tooling so researchers could work? So this was the first example. So we went and worked with Carnegie Learning, and Carnegie Learning actually they had strong engineers on their team, but they'd actually never developed tooling to actually run learning science experiments at scale on the platform. So with our help, they actually developed this tool called Upgrade, which actually allows you to launch A/B experiments on the platform. So you can actually have two sets of students get two learning interventions at slightly different timings, and then see if it actually has an impact on how quickly they pick up a concept. They've actually open sourced this tool, so it's actually available. You can actually take the Upgrade tool and apply it on your own platform. And so both Carnegie Learning has now been able to run really large-scale experiments, thousands of learners with researchers externally, but also that open source tool has now been used by other digital learning platforms to actually test out whether their strategies are actually improving learning outcomes, including some of the ideas listed. So let's go to the next one. So this is another example where one of the ideas that we were interested in was, well, if you can make these platforms and tools more available, who can run the experiment? And there's a team at Indiana University that actually started to work with Canvas, which is a widely used platform by teachers, and said, could you actually design a set of tools so teachers can actually launch their own experiments, segmenting, students in a single classroom or multiple classrooms in the school, and then see if it has any impact. And so that's the Terracotta platform, and it's been having some really interesting results. So we've been thinking about what are ways where you already go where the learners are, and then you're making it easier for researchers to design and launch experiments, so you can increase the rate at which experiments happen. So why don't we go to the next? So this idea of actually investing in platforms as a new kind of interstitial research layer and as a research sort of like infrastructure has taken off. And so we've been able to work with a number of the major funders on the public side around this. So this is all work that's happened over the past 18 months or 2 years. So it's really taken off. So the Institute for Education Sciences of the Department of Ed has run a digital learning competition where they've asked digital learning platforms to step up. They've also made grants for digital learning platforms to become research hubs, and multiple have won. And they've also done multiple partnerships with NSF around uses of AI. And then NSF, in part, has a mid-scale research infrastructure line called MSRI. And for the first time, the NSF has actually added education as an eligible category. And there's actually one applicant that's all the way through into final rounds. And so there's potential for the first time for there to be an MSRI winner. And then we, along with Gates and Walton, have actually worked with NSF on allowing more platforms and others to be able to win MSRI awards in the future. And there's growing interest from other funders as well to start to make this into a infrastructure. So if you're a researcher out there, we would love to hear about platforms you'd love to work with, as well as what are ways to make your research process easier. But a lot of this comes out of that. So that's a big wing of our work. So let's go to the next slide. So the second thing that we've just done is there's a surge of technical talent that's entering into the space. A lot of people are getting computer science degrees. A lot of people are interested in use of machine learning. But it's still, this conference being not that, but it's still pretty hard for people who are getting CS degrees to know what to do with their skills as it relates to improving educational outcomes. The most common thing you hear when we interview graduating computer science students is they'll say, well, I mentor a younger person to code. But if you said, well, what are ways you can use your technical skills to actually improve learning outcomes? Those ideas are not showing up in most AI conferences. The actual use cases that people know are pretty limited. So we've been very focused on how do we find the talent that's interested in using their CS skills. So one that, for example, we bet on is talking points. So Hijay thought of a very specific use case, but that's really taken off, which was, imagine you're a teacher and you're trying to communicate to parents, but the parents come from a lot of different backgrounds and are not necessarily English dominant. What's the way that you can send out a text message around, what's happening in school, and it can get automatically translated to all these different languages that the parents might be in. So she created talking points for that, and it's totally taken off. So when we first started working with her, she had less than 500,000 families, and now there are more than 3 million families on the platform. It's growing rapidly as school systems have a variety of different populations that are appearing. And, it's got pretty sophisticated AI that is that powers it. But it's actually helping parents and teachers communicate with each other. And KeyJ is interested in becoming a research platform, right? She's like actually working now with researchers who work on parental efficacy, on what are the right ways to run these platforms in ways that might increase parental action and improve educational outcomes. Let's go to the next one. John Whitmer, for example, is a data scientist who used to work at a major education assessment company. And he was quite frustrated / bored with that and was interested in figuring out how he could have more impact. And so we helped recruit him and suggested that he do a tour of duty in the government. And so he ended up as a fellow at the Institute for Education Sciences. And he was their first data scientist. Despite being a research agency, they didn't actually have data science talent. And so John, over the past 2 years, had a huge impact. He's on the way, IES, which runs the NAEP exam, the gold standard exam, actually uses machine learning in the way that they actually run and size assessments. It's been quite powerful as an internal change agent. And then, John's also inspired the department to create a data science unit. They think they should have a lot more data science talent, and other funders want to help more people do this tour of duty. So we're just we're at the ground floor of how do we embed more talent in the space, and would of course be happy to talk to folks around things that they want to do in this area. Why don't we go to the next one? So the third one that we sort of thought about was just market shaping, which is what are the ways that we deepen the ties between companies who are working in this area and the researchers, and just what are ways to create lots of intersections. So some of the ways that we've done that is, one, we created a tools competition that we run annually. The idea behind the tools competition is it's open globally, so we get applicants. It's for both existing edtech solutions as well as for new ones. And the idea is that it has research embedded in the base. So you've got to be eligible inside the application. You've got to be working with a researcher. And you've got to be thinking about what are ways that whatever you're doing could also contribute to the broader field of research. And then we've over time grown a number of tracks. And so we now have multiple funders who support the tools competition. And it's become a powerful way for people to raise their hand on what new ideas. The competition started in the middle of the pandemic when people were looking for new ideas, but it's really grown. And I think we've had continuing interest from new funders to grow the work, as well as are getting new applicants. So we just closed our most recent year of this and got a huge range of new applicants this year. And we'll do another round of this in the fall of 2023. So why don't we keep moving? Another way that we're doing market shaping is just running more competitions related to data. I think one of the things that you realize is that a lot of debates around AI infrastructure involve around compute, but the big other area of AI infrastructure is actually data. And by that data, I mean well-structured data sets that can actually allow you to both build and fine-tune algorithms. And in education, especially in K-12 education, this is really missing. So when I started looking into this a couple of years ago, I sort of asked what were the largest data sets that were actually getting used by AI researchers or AI tools to power their fine-tuning. And it was a very limited situation. People pointed me to a writing data set, and I looked into it, and that writing data set had actually been created in 2013, which in AI time might be eons ago. It only had 12,000 essays in it, and they were only coded as to what you would give them on a 1 to 10 score. So for example, we sponsored, along with others, a large effort to actually catalog 400,000 K-12 essays and actually build them into a data set that is tagged at the paragraph level and that is tagged around all the different things that you think about for improvement around student writing. And that, alongside that, we've now released that data set on Kaggle in a variety of different competitions. It's gotten a huge response and actually led to SOTA performance in a bunch of different areas. So I'm a big believer in this being a really powerful way that both the federal agencies and others could be sponsoring and accelerating the field, is to build well-curated data sets. And I think that also helps combat issues of bias because you can actually structure these data sets to be more representative rather than just saying, what can you find on the internet? Let me go to the next slide. And then finally, we've been this year started a new body of work around market shaping, specifically focused around middle school math. The question we've been asking ourselves is, how can we develop tools that can double the rate of middle school math progress for low-income students? This is an area which is a huge area of need. The most recent NAEP scores show that there's been a historic slide on math performance during the pandemic, even as math becomes ever more important towards wages and careers for students in the economy. And so we've been doing a lot of work on identifying teams that might have compelling ideas for what doubling could look like, and what are ways that we can support them. And we've gotten a number of great ideas, whether it's using different forms of tutoring, including digital formats, chatbots, and other forms of adaptive systems. And so this has been a build year for us, and we're doing a lot of work on this, and happy to share more. And then finally, let me just close out with, and I've sort of said this along the way, just like different ways to get involved. I think this is the work. We are ultimately part of the community, not the community, but we're always looking for opportunities for how to support. But these are just some of the ways, I think it's not a comprehensive list, that folks can get involved. So one way is just we operate a learning engineering listserv. It's got more than 2,000 people on it. People use it to find jobs. They use it to find partners and data and everything else. And it's open, and people are obviously welcome to join. As I mentioned, we run the tools competition every year, which is a great way to raise your hand on new ideas you might have or ways to tag up. And researchers often find new partners through that. We and others are always running education-related competitions on Kaggle. It's a great way to get involved, especially for folks. And then obviously we have a big push on middle school math. And then finally, I listed off a bunch of different other ways for folks who are deep in this space to get involved, whether it's imagine what's missing in this space, like what are your key data sets that you think should matter? What are the ways that we could be doing more on talent, who's missing from this area? And then what are I saw the question around, what are the additional resources that might exist, just so that it's easier for people to find the platforms to work with, the data sets and others. Jeremy's doing a lot of great work on this, and what are ways that we can just make it easier to lower the discovery cost to find out what already exists. And then, finally, machine learning is just moving really fast. As one researcher put it to me, it's like a paper of the year every week. And then obviously, I put it on a lot with the chat AI, and people are obviously incredibly impressed by how quickly some of the underlying work is happening. And so I think it's incumbent for those of us who work in education to think about what are high quality applications. For example, I'm always interested in how far are we from ML plus voice recognition plus mobile giving us a universal dyslexia screener that could just do, rather than testing students twice a year, we could just be doing a lot more. What are those high compelling use cases that we should be doing so that, we can work on all this together? So let me close there. I would welcome people, dropping questions, and we can stop sharing, and so we can see everybody for anybody who wants to drop questions in the chat. And then, we'll be happy to open it up for questions.
Thank you, Kumar, for the great presentation. During the last part of the talk, we have a question that opened up in the Q&A, and I encourage all the people participating to write their questions in there. The question we have from Lisa Loop is if there is an ontology for education that we can use to create these interoperable AI tools. What are your thoughts on that?
It's a good question. So I've seen this in a couple of different ways. One way, the short answer is I don't know if something like this exists. I would welcome folks who are watching and listening to share if they think something like this exists. On tools, I've seen this in a couple of different ways. One is there are the number of common libraries that exist in education. Tool building is actually quite scattered. So we've asked this question on the listserv, for example, which is let's say you're building an edtech startup or an edtech tool. What are common libraries you can use? So I'll just give an example. So most edtech startups will say 90% of what they work on is similar to every other edtech startup. You need some sort of an LMS type tool. You need some sort of a student identity versus like other identity tool. You need some sort of scheduling tool. You need some sort of like workflow tool for like assignments or something else. Everybody needs these tools, no matter what your special sauce is on top. The common libraries for where those are pre-built are pretty weak. And so people end up building from scratch. And so I think that's one area where tooling could be really useful. I think a second area is, what are tools that might assist key user groups? So that's why we focus a lot on, for example, researchers, which is when I was interviewing researchers, everybody was kind of like building their own way of running an experiment, almost as like a hack on the system. Like they're like, oh, well, we use Google Experiment, it throws to another screen, and that's what creates the condition. Or, oh, and like everyone was like running the experiments in a different way and certainly wasn't even documented. So one of the things that we did was just say, should researchers just be sharing their practices? And so that led to the A/B experimentation workshop that now runs alongside AI Ed, just to make it easier for people to make it easier. And so that I think is like, and then I agree with Jeremy's point in the chat, which is, then there's also like, what are ways that you can map different learner profiles and everything else? So yeah, I would be curious if Jeremy and others have ideas on, like what are the sets of common things that already exist? But I've generally found that I'll play 20 questions with someone and they know a few of them, but they don't know all of them. And we can make it easier for people to discover what these things are. So that we sort of call it like, what is the learning engineering commons? Like what are the data sets, the resources, the tooling, the platforms and others. So it's just easier for an enterprising graduate student, someone who wants to build a new tool, a technologist, somebody who wants to build an edtech company and others to discover this work.
Right. I have a bit of a follow-up question from one of the aspects that you mentioned. You touched on the platform instrumentalization to facilitate how research get access to experiments. And it makes perfect sense. And it's something that we see very, very well spread all over other technology initiatives. Another element that is equally important is being able to replicate experiments, or perhaps a bit more ambitious, to try to communicate with the educational community at large. This is the type of research question that I'm answering, and I'm calling you to help me run this. However, we do then struggle with one of the most difficult things to deal with in education, which is context, right? It's highly contextualized educational experience. So I wonder if you can unpack for the rest of us your thoughts on where is the sector moving in that direction. What I'm interested in you telling us is your views on these potential initiatives to run high-scale experiments, meaning across thousands of the schools all over the world. A little bit the parallel that comes to mind is like when we talk about medicine and some procedures that are just described, put somewhere, and then all of a sudden hospitals or any other medical related institution starts picking up, replicating, reporting results. How would that look like from your point of view in education?
Yeah, so I definitely think context matters. And it can have a huge impact on learner outcomes and the overall context of an intervention. I think the place where I would start is that if you sort of think about where learning science research often operates and then educational interventions, there's actually like this huge gap. So here's what I mean. So there's a mid-level learning science theory around spaced repetition, right? Which is once you learn something, the way you transfer into your long-term memory is by repeating it, coming back to it at some later point and basically doing recall. whether that's a quiz, whether it's at relearning it or something else. And the space repetition effect has been shown in lots of small studies. But if I said to you, like, okay, so when should I do that? Should I, like, I learned it yesterday. Should I learn it again tomorrow? Should I learn it in a week? Should I learn in a month? How much does that modulate by what topic it is, by learner profile, by anything else? You don't usually know. And the reason is that, like, all we have is the infrastructure to run small space repetition trials. And then what we will do eventually is, like, write some meta-analysis that says, here are 160 small space repetition studies. But all that concludes is space repetition is an important effect. What these sort of running experiments at scale allows you to do is say which of these effects actually are powerful, and you can actually modulate them in a variety of different ways. So for example, if you're Duolingo uses space repetition. They actually have an algorithm running in the background where they take that idea and they say, well, when should I come back to teach you that word? But how are we actually, like, advancing our understanding of space repetition based on that modulation, which is we might learn that space repetition has totally different characteristics with math than with language. And it has totally different characteristics based on learner confidence or something else. And right now, because we can't run these large-scale experiments, we don't know where these mid-level theories break, where they get accelerated. Similarly, I'll give another example, which is we don't actually, most studies will take one type of learning, these sort of mid-level theories, and test it out. But we also, like, don't actually test two of these mid-level theories against each other, right? So when do worked examples and space repetition compound to actually accelerate the learning? And when are they just, like, it's as if they don't matter, or do they actually take away from each other? They confuse the student. Because we run, most studies are small, you can actually run compound effects of two studies on top of two types of learning science concepts. So I totally agree with you that, like, context really matters, but I think, like, one of the ways we can start to unpack how context matters is start to take these larger studies and then do sub-analyses for why there's differentiated results. And I actually think that will lead to interesting and different results. It's similar to, like, if you think in, like, computational biology, and you say, well, is computational biology teaching us new ways about how the body works? Like, clearly biology is biology. Like, we have to understand what is the actual flow. Often what a computational biology approach does is that it's clue finding on new questions to ask. So if you say, hey, it seems like every person who ends up having cancer has this spike in their genome, that doesn't actually show you the causal pathway. But, like, you can now, like run a different set of experiments to try to figure out that pathway. And my question is like, do these large-scale experiments give you new causal pathways to review, which just doing small studies might just lead to a lot of for where things might go.
Yep, thanks. We have a second question in the Q&A tab here from Simon Atkinson, going back to the ontology question, and he's curious if there is a prospect of development. IMS has been putting a lot of effort to try to provide these standards to capture a lot of information around learning experiences in general. Any initiative to tackle AI or ML in that space?
Yeah, I haven't, I've been tracking a little bit, the Icicle work and sort of questions around, like, what should be the common frameworks? I guess I don't have, like, a good mental model for when these sort of common framework efforts, like, when they take off, when they work, and what they solve for. I I do think that one challenge or opportunity I see is that most people who come out of the machine learning space don't have good context knowledge about education itself. And so if you often will see papers, it's like the same paper analyzing, edX data and saying, can you predict like what the next thing should be? Or like the narrow set of, and I think what it reflects is just that like, they don't have a sense of what are the most interesting questions. So I guess my question, I think, would be, what would be the sort of common protocol that would make it easier if you're someone who's doing cutting edge work on reinforcement learning or cutting edge work on various LLMs, to then like readily be like, these are the ways I would tag it into key questions around how people build learning products. So if somebody said, oh, here is the protocol for the orchestration algorithm that decides like when the teacher provides extra tutoring, you should show up and see if your algorithm does better than this. That then they could say, oh, okay, I'm running my reinforcement algorithm against this existing one. Can I do a better job? And like in computer science, you have all these sort of benchmarks. And so people can walk up and run it against the benchmark and see if they've done a better job. And they need to understand something about the benchmark, but not everything about the benchmark. And right now, I feel like we don't have enough good benchmarks in education. So like advancement in CS, like how much better is this, right? And so, I saw some like interesting examples where with the chat AI that just came out, where people like fed it SAT questions. So it's like, these are all like efforts to like come up with new benchmarks effectively. Like, what's the benchmark? But like, my question is like, we don't have benchmarks to say, well, what's the benchmark for what an algorithm does in this instance? And then I could see how much of a better job am I doing at meeting, matching the learner profile or using this. And so that's one of the things we're hoping with these various data science competitions where, let's say you're doing it on writing, you could say, well, we already know what expert teachers would give as the writing score and the feedback. So you could say, well, how well is this algorithm matching expert writing instructors? So at least we have a benchmark, and then you can evaluate new algorithms against it. So I do think benchmarks are quite powerful. I just have less experience on the where the protocols net out.
Okay. I haven't seen any other questions in the chat.
I saw, was there a question in the chat about contributing, what efforts have you contributed towards identifying, hiring learning scientists? Do you see that one?
No.
Well, I can answer that one. So it said, what efforts have been contributed towards identifying and hiring learning scientists with expertise in learning theories to ensure that these data are used in a way that's valid and aligned to the science of learning? So yeah, I think that's like a great question. So in general, that our general hypothesis is that learning scientists are being underutilized, that there's a huge gap between all the folks who are doing really powerful work on advancing the science of learning and then everything else. People are building ed tech products, people who are doing lots of other work on education. And so we have been trying to build in learning science research at every step. So for example, as I said, in the tools competition, it's like a requirement that you cannot actually put forward a proposal unless you have a research partner. And how is that research partner improving your ability to actually do the science of improvement? So how are you both building evidence based on learning science and then also advancing it? The second is just that we try to, at least as far as we can, build up the field of what researchers are active in this area and then connect them to the platforms we're finding, to these data science competition and others. But yeah, we would of course love to do much more of this. I mean, part of our goal is we want to be helpful to the community in being able to do more ambitious work rather than, but our hypothesis is just that right now, we're relying on the PI being entrepreneurial. We're not making it that easy to go find the platform, find the data, find everything. Like it's like a totally A to Z process where researchers have to just do everything. And I think that just means that they can do less actually, because when you expect them to do everything, they only have so much resources under a grant, they only have so much time. What are ways that we can build more things to make them allowed to be more ambitious?
Excellent. We have another comment in the chat agreeing with the vision that we've been discussing of education being very contextually dependent. I wanted to run by you another question that I was thinking about. I like the part where you mentioned about motivation and how it is a very special regulator of the overall learning experience or behavior of the learning in a learning experience. I wonder if you can share with us your thoughts or your views of the connection between motivation and AI or machine learning, because there are quite a few challenges. First is detecting motivation reliably, but then there is a second one that is probably a bit more significant, which is how to act, right? It's observation and action. Where do you think are the possibilities or the future or initiatives when we tackle this observing and acting on motivation of a learning experience?
Yeah, I mean, I think we have to just start with a good degree of humility, right? Because I think in general, the big argument since the mid 90s on ed tech has been, this is going to blow your socks off. Students are going to Library of Alexandria, they're gonna be so motivated, just wait. And what we find is technology is by itself not a solve for motivation, that highly motivated students will eat that stuff up, whether it's MOOCs, whether it's individual platforms. So I think it's nothing is just automatic. I think the pieces that I think are interesting is, one, can tools get better at noticing motivation? So this is a whole can we pick up mind wandering? Can we pick up confusion? Can we pick up when students are frustrated? And I think there's room for much more work there. Second is, motivation is often human mediated. So rather than the idea that the AI will motivate you, the idea is just that what are ways that you're optimizing for other human time so that you don't get demotivated, right? It's the feeling of, I have a team. They will be demotivated if I never get back to them. So what are ways that motivation is a flow system, right? So maybe what the AI is helping you do is just helping the learner be in flow by making sure they're getting positive interactions with other humans. And then I think the other part is just that just this feeling of agency and flow, right? So what are ways that you're creating lots of opportunities to feel like you're getting mastery, you're getting traction, and there might be lots of ways that you could create that sense of motivation. But like I said, where I started, I think we should just not presume kind of a gee whiz attitude on motivation. But the reason I think it's powerful to sort of think about this is that as some of these tools get stronger, if they can sort of start to develop loops around motivation that are powerful, that becomes this really powerful different engine, right? Because suddenly, it's what people often theorize for game developers. It's if you can create the thing that somebody plays for 12 hours without stopping, that's powerful. The question is that we just don't know. Learning design is often about, putting people in a state of discomfort. That's actually where the learning is happening. So you're constantly modulating between discomfort and a sense of speed and running, and done well, you actually internalize that as fun, but it just takes a little bit of work.
Yeah. All right, we have a couple of other comments in the chat, but not necessarily questions yet about the the impact that educators have in taking that motivation from the learners. If we don't have any other questions, then I think we're going to wrap it here. Thank you, Kumar, for your talk. It's been not only very insightful, but also very relevant to the event and to the attendees to the event that have expressed so much interest, so much curiosity, and it's very refreshing to see so many initiatives also in this space. So thank you for your insight talk, and we'll be in touch throughout the rest of the event. Thank you, everybody.
Thank you. Thank you again for having me, and thanks everybody. And then, yeah, feel free to follow up. We're happy to help.
Have a good day, everyone. Thank you.
Bye.